Scalar is a quantity that has magnitude only, or you can say a scalar is a quantity that can be completely specified with its magnitude. Now the question arises that what a magnitude is. To describe magnitude, I can use the word size. Means it will represent the quantity or number of something. Magnitude of any physical quantity is the answer of how much the quantity is. Magnitude is always a number written with a suitable unit. For example, mass of a book, that is you can say 500 grams. So in this calculation, the value 500 is the magnitude, and its unit, that is gram. Now moving on to the next topic, that is vector. Vector is a quantity that has both magnitude and direction. If any one of these things are missing, vector cannot be specified. Or we can say a vector quantity is described completely only if the magnitude and direction both are stated. For example, it is not enough to say 10 Newton of force, but rather a force of 10 Newton acting vertically downward. The next topic in this regard that we are going to study is addition of vectors. So far we have discussed two quantities, scalar and vector. Then a question arises, why we are discussing only vectors? So its answer is, scalars are added or subtracted by simple mathematics rules, while vectors are not, and they are not supposed to be solved by simple mathematics. They have special techniques that we call vector algebra. So in the next few minutes we are going to discuss some techniques that we use to calculate, that we use to add the vectors. There are two methods that we use to add vectors. First method is head to tail rule. We can represent note that these two methods that we are going to discuss in this video are graphical methods. Vectors are also solved numerically, but the methods that are in our syllabus are graphical methods. So we are going to discuss head to tail rule, that is one of the graphical method of vector addition. The first one, head to tail rule, starts from, first we have to know that a vector can be graphically represented as an arrow whose length will represent its magnitude with a suitable scale, while the arrow represents direction. In the head to tail rule, we consider two vectors. Let's suppose vector A and vector B. The vector from where it starts is called as the tail of the vector, and where it ends is called as head of the vector. The rule is simple, that we join head of the first vector with tail of the second vector. And the resultant vector will be the one that starts from first vector and ends at second vector. Now, applying these rules on these two vectors, that are A and B, we are drawing the first vector, that is A, and the second vector B will start from the head of the first vector, that is A. So, according to the rule, the resultant vector will start from the first vector, that is A, and ends at the final vector, that is B. This vector represents resultant, or you can say this is the product of or sum of these two vectors A and B. Now we are discussing the second graphical method for vector addition, that is parallelogram law. Or completely you can say parallelogram law of vector addition. This law is also a simple law in which we consider two vectors, as we have considered in the previous example, vector A and B. Now, vector A and B are joined by their tails. Both tails are joined and a shape is formed like this. Now, what parallelogram law states is, make a parallelogram, draw a parallel vector A here and vector B parallel to here. Now the shape is of a parallelogram, and the diagonal of the parallelogram will represent the resultant, that is A plus b. So far we have studied these two laws, but there is a difference between these two laws according to their application. Head to tail rule can be used to add more than two vectors at a time, while parallelogram law only two vectors. Parallelogram law added only two vectors at a time.